Hey guys, Mr. Gran here, and this lesson is on 7.4, Similarity in Right Triangles. In this video, we're going to talk about some special similarity that happens in right triangles, and we're going to come up with some equations that are going to help us solve some problems in the second video. Okay, so looking at our right triangle, we've got the right triangle. It's this big right triangle, ACB, or ABC, and it's tipped down and laid down on its hypotenuse. And then it's divided in a really special way. It's divided by a perpendicular line, so it crosses at a 90-degree angle and connects up to the very top at C. Sometimes we will we'll label that H because it's like the height of the triangle. And it's a lowercase h where we've got capital letters for the points. The special name for this, though, we usually don't call it the height, we actually call it the altitude, which is sort of just a special name for that we use in triangles when we're talking about this type of a height. Altitude, right? If you're flying in a plane, the altitude is like the height of that the plane is flying in, right? And we also use it in some triangle stuff. All right, what's special about this is that this splits this triangle up into a total of 3 similar triangles. So 3 triangles that are proportionally the same. And it only does this when we've got an altitude here where this is a perpendicular angle, right? It has to be 90 degrees or else it doesn't split this up in that way. All right, so when we're thinking about these, right, this is how one of these triangles gets split up. We've got our overall triangle, ABD in this case, and that's represented here. That's the big triangle. And then it splits it into 2 smaller triangles, right? This red one gets split down to here, and this blue one gets split down to here. Now notice that the position of the angles change a little bit. So in the big triangle, they both use angle D, but that angle D is the same as this angle right here in A. And then this base angle, right? Both the big triangle and the little blue triangle have angle B down here in the base, but that corresponds with this part of angle A in the red triangle, the middle triangle. And all of them have, and then it's similar where both the blue triangle and the red triangle have 90 degrees at point C, and that corresponds with the big triangle 90 degrees in A. And the ratio of the hypotenuses is going to be the same. The ratio of the 2 legs are all going to be the same in these. They're proportionally similar. Okay, so how can we use this? We're going to call this the middle rule, where we will say that this, instead of an H, I'm going to put an M there for middle. And we are going to relate that to the 2 parts of the base. So we'll call this P1 and we'll call this P2, right? So part 1 and part 2 is what that represents, because we've taken this whole side and we've split it up into 2 parts, okay? Now if I take out the 2 triangles that I need here, so I'm going to look at this triangle right here, right? If I take that out and redraw it, M is the height, and then P1 is the base, right? So part 1 is the base. Then, if I look at the other triangle, the other it's not half because it's bigger, but we'll think of it as it's split into 2, so we'll call it the other half. If I take that out and I kind of rotate it and I redraw that, right? The longer side is P2. And the shorter side, the base now, is M. Well, we know that these are similar triangles, and so that means that the ratio, if we go the ratio of the heights, P2 over M, that is going to equal the ratio of the bases. And I go in the same direction. So the M is on top now, and the P1 is on the bottom. And so what that means is now if I solve this by cross-multiplying, I get that M squared is equal to the product of P1 and P2. Or we could think of it this way, that the middle squared squared, so this side squared, is equal to the part, we'll call it part 1, times part 2, like that. All right, we've got one more rule we're going to create, and this is called the outside rule. And so for this one, I'm going to put an O. We're going to talk about this side over here. And we're going to relate this to our part. That'll be this part. And then we're going to relate it to the whole thing. So the whole, like, base. We'll call that W. All right, well, same thing if I pull out this triangle, then O is the hypotenuse and P is the base, so the outside and the part, right? Then if I look at the entire thing, so I take that and I kind of flip it around so it orients the same way. We get the bigger triangle here. Now the W, the whole base here, that is now my hypotenuse. And the outside, what was the hypotenuse of this triangle, is now the base of this triangle. All right, same thing, if we set up our ratios, I'll go W over O, and that is equal to O over P, so the outside over the part. And we get a very similar looking equation, that O squared, and now this is O and not 0, right, is equal to W times P, or P times W. And so the other way we could think of this is that the outside squared is equal to the part times the whole, where we're talking about the outer side, the part that it's connected to, and then the whole base.